All right, in this video, we're going to be multiplying monomials together. Let me give you an example of a monomial. 4x squared. That's a monomial. Now why? Well, mono means one, which refers to the number of terms. So this 4x squared, this is all one term. So we're going to be working with things like that. What won't we be working with? Well, what about 4x squared plus 5x? How many terms are there? 4x squared is the first term. 5x is the second term. So this is not a monomial. This is actually called a binomial, because bi means two, like your bicycle's got two wheels, for example. So not yet. Go on to the future videos if you're ready for binomials. But we're just going to be working with multiplying monomials together. So can we grab an example to look at? By the end of this video, it should be very easy for you to multiply this monomial, 5x squared, by this monomial. And I'm actually going to just give you the answer right here. And then I'm going to slowly walk you through some other questions that will lead us to why. But the answer to this is 20x to the 8th. 20x to the 8th. Take a look at that. See if you can notice a pattern. What did we do with the 5 and the 4 to get the 20? What did we do with the 2 and the 6 to get the 8? That's getting a little ahead of ourselves, though. Before we can dive in there, let's remember some of the exponent properties, a very specific exponent property that you should have seen before. So if we look at 5 squared times 5 to the 4th power, what's that going to equal? Well, if you remember your exponent property, and we'll do a quick reminder here, I always add my exponent. So 5 squared times 5 to the 4th power is equal to 5 to the 6th power. What about 3 to the 4th power times 3 to the 5th power? Well, again, I always add my exponents. 4 plus 5 is 3 to the 9th power, and my base of 3 stays the same. Great, so if you remember that, now we're ready to really start multiplying monomials that are new to you. And the new thing here is that we are going to have variables involved. So let's take a look at two monomials here. The first monomial is 4x, and the second one is just x. And the 4, I don't have another number to multiply by. I've just got the 4. And can I simplify x times x? Well, that's equal to x squared. Remember, if I just have a variable and there's no exponent there, it's equivalent to having a 1. So x to the first power times x to the first power. I add my exponents like we just talked about, and 1 plus 1 is equal to 2. Great, so let's move on to another one here. If I have 4t times 3t, well, 4 times 3 is going to be equal to 12. So I've combined my coefficients. And then t times t, again, think of a 1 being there, is going to be t squared. So the answer here is 12t squared. So let's keep going. And once you get into the rhythm of these, they become pretty alright. So what if I had 4p to the 5th power times, let's say 5p to the 3rd power? What would that equal? Well, you're going to notice a pattern here that we've been picking up on, which is that I'm always going to multiply my coefficients. So 4 times 5 is going to equal 20. And I'm always going to add my exponents. So p to the 5th and p to the 3rd is p to the 8th power. So I multiply 4 and 5 to get 20. I add 5 and 3 to get 8. And if you really want to see why that is, let's really dive in here and let's break down this first term. Let's break down 4p to the 5th. I can write that out as 4 times p times p times p times p times p. That's 5 of them. It's 4 and 5 p's. And then that second term I can write as times 5 times p times p times p. What I'm going to do is I'm going to group my numbers because I can work with numbers together. So let's put 4 times 5 at the very front. And then it just becomes a matter of how many p's do I have. We'll put all of those together as well. So I had 5 p's, so there's the first 5, and then I had 3 more. And we can simplify this crazy looking expression by just multiplying by 5 to be my 20. And then writing this with an exponent. That's the beauty of exponents. That's why we have them, is we can write a crazy expression like that as p to the 8th. And you'll notice that this is, of course, what we got the first time. So great. What about 5y to the 6th times negative 3y to the 8th power? Again, multiply the coefficients, add the exponents, and I've got a simplified expression. Let's get really crazy here. Let's have a little fun. So we've noticed the pattern. Let's have a little fun. You're saying, I can do more. Negative 9x to the 5th power times negative 3. Use parentheses there. You always, when you have a negative in front, you want to use parentheses. Let's do x to the 107th power. If I would have showed you this before this video, you would have said, oh my goodness, there's nothing I can do. I'm boxed. There's no way out. But now you know that it's as simple as follow the rules. We're going to multiply the coefficients. Negative 9 times negative 3 is 27. 2 negatives is a positive, and 9 times 3 is 27. I'm going to add my powers. 5 plus 107 is 100 and, not 2. That was a mistake I made there. Let's get rid of that. Give me a second chance here. Well, it's all about second chances. 5 plus 107 is 112. And so this crazy expression, which is 2 monomials, here's the first, here's the second. When we multiply and simplify, we get another monomial, which is 27x to the 112. I'm going to leave you on a cliffhanger here, which I'm going to show you a problem. What variable should we use? You notice I've been trying to vary the variables up to show you that it just doesn't matter. That's an ugly 5. Let's get rid of that. Give me a second chance on that one too. So let's look at 5x to the 3rd power times 4x to the 6th power. And I'm going to show you a wrong answer. I had a student that I asked to do this, and here's the wrong answer that they gave me. They told me 9x to the 18th power. That's terribly wrong. What did they do wrong? What did they do wrong? I want to think to yourself, what have we been talking about? What did they do with the 5 and the 4 to get the 9? What should they have done? What did they do with the 3 and the 6 to get the 18? And what should they have done? That's multiplying monomials by monomials.